Good morning, student. Welcome to today's class. Today we will discuss about some special purpose of diode, okay, which is Zener diode and light-emitting diode. Okay, these two diode we can discuss in today's class. Okay, so first of all, what is diode? In diode means there is two electrode. Okay, in previous classes we have already said diode, triode, pentode. Okay, diode. Okay, diode one the this uh, diode this diode word. Okay, this di means two and odd means electrode. Okay, so this device, which device uh, has two electrodes, that is called diode. That means previous classes we have discussed about p-n junction. Okay, that is also called p-n diode. Okay, due to it has two electrode. Okay, this is p-type electrode and this is n-type electrode. Okay, p-n junction. Okay, so and again these diode, the most common application of the diode is rectification. Okay, the common work of diode is rectification. What? Now, like a filter. Okay, rectifier like a filter. Okay, it filter something. Okay, or it remove something or unwanted things from the desired output and and give desired output. Here the rectifier diode are used in power supplies to convert AC voltage into DC voltage. That means this diode rectifier is used for converting AC into DC. Okay, but there are or the diode does not only rectifier function, the some of the more common special purpose diode are there, that is Zener diode, light emitting diode, photodiode, tunnel diode, vector diode, and Shockley diode. Okay, today we will discuss about Zener diode and light emitting diode. Let's start. What is Zener diode? Okay, a Zener diode is a special type of diode that is designed to operate in the reverse breakdown region. That means this diode is operate in reverse biasing mode. Okay, for reverse biasing mode, the uh, in PN diode, that PN diode is act as a Zener diode. Here the diode P side in reverse bias in Zener diode always work in reverse bias. P type is connected to the negative and N type is connected to the positive. Okay, this is positive and this is negative. This is called a reverse biasing of PN junction. In previous classes we have already studied about this. Okay, and this Zener diode is used in reverse breakdown region. Okay, reverse breakdown region means the minimum. In previous classes we have seen that what is reverse breakdown region means the minimum reverse biasing or the minimum reverse voltage used, or the minimum reverse voltage needed for breaking the uh, barrier of PN junction is called breakdown voltage. Okay, or reverse breakdown voltage. Okay, and this reverse breakdown region, this Zener diode is worked. Okay, okay, see, this much is here, this is breakdown, this is breakdown breakdown, okay, and this much is Zener breakdown region, okay. This much is Zener breakdown region. After breakdown of potential barrier, the Zener breakdown region started, okay, and this is in reverse voltage or reverse biasing. This is for forward biasing, okay. In previous classes we have studied VI characteristic of PN junction. This is forward biasing of this is forward biasing of PN junction, and this is reverse biasing of PN junction, okay. And Zener diode, a Zener diode is heavily doped to reduce the reverse breakdown voltage. That means Zener diode heavily doped. Uh, Previously I told you that the doped means the mixing, the amount of mixing impurity in the semiconductor, like trivalent impurity for p-type semiconductor and pentavalent impurity for n-type semiconductor. That amount or how much amount we added the impurity to our semiconductor, that is called doping process, okay, or mixing the impurity in the semiconductor is called doping process, okay. And here in Zener diode is heavily doped, that means so much impurity are there to reduce the reverse breakdown of voltage, or and this cause a thin this cause a thin depletion layer. That means reverse breakdown voltage decreases, that means the depletion region or the breakdown the potential barrier region is very thin, okay. As a result, a Zener diode has a sharp reverse breakdown voltage Vz. Sharp reverse breakdown means suddenly breakdown or suddenly increased the reverse current, okay. This is clear from the reverse characteristic of Zener diode. That means this, here you see the reverse current is sharply increased. That means here and sharply increased, okay. So this this due to this happily doped, the reverse breakdown voltage decreases, okay, reduced, so that the depletion region or potential barrier region is thinner and thinner, and the the Zener diode has sharp reverse breakdown voltage Vz, okay. As the curve reverse reveals, two things happened when Vz is reached, okay. That means Vz, the reverse breakdown voltage reached, there are two things happened. The diode current increased rapidly, okay, and the reverse voltage Vz across the diode remain almost constant. That means from the curve you see this is the current and this is the voltage and this is the Vz, okay, reverse breakdown or breakdown voltage, okay. And at Vz the current increases, this the current, this is the current increases rapidly or sharply, but the voltage Vz is constant, nearly constant. That means uh, little bit of increase of the voltage, but it is nearly constant, but the current increase rapidly, okay. These two things happened, okay. In other words, the Zener diode operated in this region will have a relatively constant voltage across it, regardless of the value of the current through the device. This permits the Zener diode to be used as a voltage regulator. That means due to due to the due to the constant voltage, or due to the voltage is constant in the Zener region, uh, Zener region, but the current increases, or in spite of increasing of current, the voltage is constant in Zener diode, okay. So it can used as a voltage regulator. Voltage regulator, what is voltage regulator? In voltage regulator we regulate or we control the voltage inside our Zener diode. That means we get a diode which is termed as a 5-volt voltage regulator. That means it didn't increase the it didn't allow to increase the voltage inside or throw it above 5 volt. Okay, that means it protect from over voltage. Since it termed as a 5 volt, it didn't allow the voltage to increase above the 5 volt, but in that time current can increased heavily, but the voltage cannot be increased above 5 volt. Okay, so this operation or this control of voltage operation is called voltage regulator. Okay, and now let's see light emitting diode. What is we called LED, and we commonly use these LEDs in our household, or we uh, we uh, we know about these LEDs, but how these LEDs function or work, let us see. Okay, a light emitting diode, a light sorry a light emitting diode, which is LED, is a diode that gives off visible light when forward biased. This diode is in Zener diode work in reverse biasing, but this LED or light emitting diode worked in forward bias, and when it forward biased, it emit visible light. Okay, light emitting diode does not made from silicon and germanium, but are made by using element like gallium and phosphorus and arsenic. The light emitting semiconductor is didn't made up with what silicon and germanium. It is made up of with gallium, phosphorus and arsenic. Due to silicon and germanium, the emission of light is not that eminent. Okay, so we use arsenic and gallium and phosphorus for that more amount of light emission. Okay, for example, when a LED is manufactured using gallium arsenide, it is produced a red light, and by increasing the amount of gallium or phosphorus or arsenic, or by varying these amounts, we can get what we can get many colors. Okay, for example, if we manufacture using gallium arsenic, the LED will produce red light. Okay, if we LED is made up of gallium phosphate, this produce green light. Okay, and how it works, that when light emitting is forward biased, as shown in figure 2i, that means this. Okay, p type is connected to positive and n type is connected to the negative. Okay, when this p-n junction is connected forward bias, the electron from p type material cross the p-n junction and recombine with hole in the p type material. Okay, in previously in p type characteristic we see that in forward bias the positively hole, or the electron from p side combined with hole in the electron in n type material cross the p-n junction and combine with hole in p type material, and when the combination takes place, the recombination electrons, okay, release energy in the form of heat and light. When this combination of electron when the combination process of electron and hole is happened, there is a little bit of energy radiate or loss in the form of light and heat. Okay, and in the silicon and germanium, this energy loss or energy radiated in the form of heat most of the energy is radiated in the form of heat. So the light emitted very low, which is not visible. So we cannot use silicon and germanium for LED or light emitting diode. Okay, but in arsenic and phosphate, or arsenic and phosphor, um, and another one is what, gallium. Okay, gallium, arsenic and phosphorus, we can get the energy radiation in the form of light, or most of the energy radiation in the form of light. Okay, that light is visible to our eye, and we can use that LED as a light emitting or as a light. Okay, and this is the schematic diagram of the LED. Okay, this is positive end, this is positive end, remember this is positive end, and the tip of the arrow is negative end, and this direction or this arrow shows that the light is emitted or the light is produced from the LED. Okay, this is the schematic diagram, remember this. Okay, thank you.